Hi folks, so the question we have in front of us here today, guys, is a question from the Graphics in Design Communication textbook. It's on page 99 and the topic we are covering is under the topic of perspective projection. Okay, so you can see the question we have here, okay, and I've obviously already populated with some information, I haven't done it previously. But the question itself, okay, we're given an object here and the elevation with some various heights, okay, that are put in meters. You can see here 6 meters, 3 meters and 8 meters. And then we've also got the plan, which is where we're going to basically project or do our perspective from. Now, our plan view is inclined at 60 degrees or 30 degrees, however you want to call it, to the vertical plane, okay, so it's not obviously sitting flat, it's obviously been twisted, okay, it's not sitting like back up against the wall. And the measurements then for it is basically how you would work it out. Sometimes you're given a scale, guys, okay? It's not always going to give you the exact measurement. And our scale in this case is 1:100. What that means is 1 millimeter on our sheet, which is why I've kind of written, it's hard to see there, but it says OS on sheet, is equal to 100 millimeters in reality, IR, okay? So let's apply that. I'll start off with this face here. So from corner A to here, okay, we can see it's 5 meters and 2 meters. Now that adds up to 7 meters altogether. And 7 meters, if we were to break that down into millimeters, because that's what this is here, 7 meters into millimeters is actually 7,000. So you can see here I'd previously written 7,000, okay, 7,000, okay. And what I'm going to do is I'm going to apply that the scale here then. So I want to divide 100 into 7,000. So I cancel off the 2 zeros. Cancel 0 and 0 and it leaves me 70. And what that means is my scale here, worked it out, that means the length of this side is 70 millimeters. And then obviously 5 and 2, so it was 50 and 20. Okay, so quite easy, but it's just a case of understanding behind it. So 3 meters equates out to 30 millimeters, 6.5 meters is 65, 2.5 is 25, okay. And then these guys in here, this distance here is 10. Well, it's 1 meter, but 10 millimeters, and then same distance out the opposite side, which is 1 meter, which is 10 millimeters once again. Okay, and we can see here perpendicular angle up here, so we're given 60 degrees. We can see it's perpendicular there. That makes this angle here 30 degrees. Okay, our ground line to our horizon line is 5 meters. What that means is it's going to be, I haven't written down in, that's actually 50 millimeters. Okay, and then from corner A to our spectator it's 10 meters, which is 100 millimeters. Okay, so that's what we're going to do. We're going to set up this question, and as you can see I've already drawn in my plan view here. Okay, so we're going to start with that there now. So just zoom out there. So as you can see I have it set up in a landscape format. Okay, I've done it in landscape because I do think it fits in landscape. If you do it in portrait, my advice is keep it to the left of the page if you decide to do it in portrait, because for your vanishing points you'll see why in a second. Okay, so from corner A I've already measured down a distance of 100 millimeters to find my spectator. So setting up the question, this is what we're going to start with. We're going to start off by setting up our cone of vision. Your cone of vision is set up as you imagine a person looking at the object. The furthest right point they see is here and the furthest left point they see is here. Okay, and you'll see here if I connect them both to the spectator, what it helps us create is what it looks like kind of as a cone. Okay, and that there is known as your cone of vision. Sometimes I'll write it in, you don't always have to. Now this question, okay, is going to be helpful because we're using height lines, okay, which we have practiced. Okay, you should have practiced up to this point. Now with our cone of vision, okay, that's the furthest left we see of it and that's the furthest right we see of the object. What we want to do is get the direct middle of that, which is known as our line of sight. And to get the middle of that, any angle, to get the middle of it, we're going to bisect it. So just using your compass on the spectator, pick a distance, any random distance, as long as you keep it on your compass. Cut, and then same distance, I'm going to keep it here. Swing an arc from both cuts where the two arcs cross each other. What that has done is it has bisected the angle for me. And I'm going to put this in kind of like a hatched line there, like that. That hatched line, okay, is known as my line of sight. So I'll write that in there. You don't have to, once again, but just for the purpose of this video I will. Now, the line of sight is important because the line of sight helps us to set up our picture plane. Okay, and we know the picture plane, it didn't say it, but it does pass through the corner A. It was in, it was on the previous page. So the picture plane is perpendicular to the line of sight. So setting up my spectator on my line of sight, I'm going to bring my 30-60 set square underneath my set square. Okay, and then what I'm going to do is I'm going to twist. I always like to use the long edge of the 45 set square. I'm going to twist this and rotate it. And what that has done is it has created a perpendicular angle to my line of sight. That angle in there is perpendicular, but I'm going to put it through the corner A. Okay, and sometimes I think based on the 30 degrees of this edge, I think I'm going to need it just a little bit further. Hopefully that'll be far enough. Okay, and that there is our picture plane. So usually P and then P, but I'm going to write in the full, so that's plane and picture. Okay, so there's our picture plane. Now what we want to do is we want to get set up, because our ground line and horizon line, we're going to draw them in a second, but before we get them, okay, what we're going to do is set up for our vanishing points. And our vanishing points are going to be dictated by the direction of the surfaces of the object. Okay, so we have our object is either going in this direction, so we can see lines going this way, okay, or it's going in this direction. Okay, so we can see lines going in this direction. Okay, so what we're going to do is, from the spectator, we're going to go parallel to those faces, and I know this one is at 60 degrees, so check up at 60 degrees there. Okay, as you can see, 60 degrees, and then faces going in this direction are 30 degrees from the spectator. So just about gone far enough there. Okay, and that cuts my picture plane right here and right here, and that's going to help us locate our vanishing points in a moment. Now, inside in class, to alleviate a little bit of stress, obviously doing slide and set squares the whole time, what I like to do now to set up my ground line and my horizon line is I actually like to pick up my sheet. Okay, so take the masking tape off the corners. Okay, and we're going to set up our T-square so that it's in line with our picture plane. Okay, might be a little bit awkward to do at the start, but it is a bit of a time-saving technique. Otherwise you would have to do a lot of sliding set squares, okay, to be able to complete it, unless you have an adjustable set square yourself. So, using the picture plane, I'm going to line up my T-square so it's in line with the picture plane. Try and bring it into the middle now of the page, or the board. Okay, so that's roughly, just pulling that down a little bit there. There we go, happy with that. So tape down your corners once again, when you're happy. So 4 corners taped down, and now I should, as I previously said, I should now have my picture plane in line with my T-square, and it is. And what we know from doing these questions is, and I'm just going to pull that down a little bit there, so a little bit more, it's awkward enough one to fit in, there we go. What we know from these questions is that the picture plane, the ground line and the horizon line, they are all parallel. Okay, so I am going to set up my ground line. I'll do it here just so it stays within the camera shot. Okay, you can see just staying within the camera shot. Usually when I'm setting up my ground line, I like to keep the ground line the distance below and the horizon line just below the spectator, but for the purpose of this video it doesn't matter. So I'm going to keep my ground line something like that down there. Okay, it doesn't have to be as long as the picture plane, it only needs to be something maybe down here. Ground line is essentially where the person is standing. So there's my ground line, and from the question previously it said the ground line to the horizon line was 5 meters, which is 50 millimeters. So above the ground line I'm going to measure up 50 millimeters, and the horizon line I keep it as a light line. So the distance between this line and this line was 50 millimeters, and I'm going to call that my horizon line. Now for that part of the question you get a big chunk of marks. It's 30-40 marks for that part of the question. Okay, last little bit, going to locate our vanishing points. Now this is helpful because now I can just transfer them straight down rather than doing sliding set squares. This one probably had to come a little bit further there, so probably should have put a line outside it, but it'll do. So at that point there I'm going to call that one VP2, and the one over here on the right, or on the left, sorry, VP1. Okay, so there we go. That is our question set up. Now we can actually start building our problem. Okay, so always guys, what you're trying to do is we're going to use the object, so I'll just bring this back in here, and this is essentially what we're making here. Now if I look at that, it's kind of made up of kind of three structures. I've kind of got this block here on the left, kind of like the chimney off to the left hand side, okay? Then I've got this chimney attached on at the top, okay, which is here. And then I've kind of got this house-like structure here, where I've got a small face here at the front, and then I've got a big face here at the back, and they're obviously connected. Now, the way I would do it, and there's many different ways you can go about it, okay, I would possibly start off with this face here, okay, and then maybe creating this face here as well, okay, that face right there, okay. So I'm going to start off by creating this face here, okay, and then creating this face. And then with that face then we'll be able to start on this, and then we'll get onto this guy right at the end, okay. So, actually just bring that back there. Just determining on them, the height of this face is 3 meters, as you can see, and we know 3 meters is 30 millimeters high, and the height of this guy is 8 meters, so that's 80 high. Okay, so 30 and 80, I'll just zoom in there so you can see it, 3 meters and 8 meters. Okay, so I'll zoom back out there. So what's important to note is, because our picture plane is passing through the corner A, if I project A down to my ground line, A is hitting right here. That's my A there. Right there. Okay? Because A is touching my picture plane, I can take that, whatever surface A is on, or whatever point A is at, I can take that as true heights, okay? I can take any heights on that as true heights. And I know corner A has a height of 30 millimeters. So, straight away I can measure up 30 millimeters up along corner A. So from A, measure up 30 millimeters. So I've measured that there. I can heavy in that edge, because I know that's a heavy edge then. Okay, so heavy edge, and what I know is the face for the front face here, as I said, okay, is going in this direction, okay, and parallel faces will all go in one direction. So all these lines here, this one, this one, this one, this one, and this one, all of them are going in that direction at 60 degrees, lines up with this, so they're going to VP1. So from here, vanish to VP1. These are construction lines now. I know they appear heavy on my page. So vanish to VP1, okay? And to find where that face finishes, it actually finishes right here, okay? It's going to finish there. That's where that square face is. Obviously we're seeing it as an edge view in our plan. So to find where that finishes, I'm going to line up my spectator with that point there. I'm going to project it down to the spectator, but stop it at the pitch plane. Now you could extend it on, but I like to stop it at the pitch plane because I think it keeps it neat and tidy. Because that is the spectator's eye view of that edge there. Where it hits the pitch plane, project it down. And there we have it. That is the front face of our object. I can heavy that in there. Okay, just to show you again. That there is this guy's front face here. Now what we're going to do is we're going to work on to this face. Okay, because we have this edge here, A. Because technically that there was our A there, and we measured up 30, we vanished to the left, now we're going to start vanishing off to the right. So I'm going to use the height of 80 millimeters here to get up to the chimney. Okay. Also, what's important to note, and I should have actually noticed this bit here is 6 meters, so I'll zoom in there. This bit here is 6 meters, this part of the roof, but if you notice, it's the same height as the roof as well. So that's going to be helpful, because that roof obviously kind of continues back there and it probably joins up like that. Obviously it's connected on with a chimney here, but that's 6 meters high as well. So that's going to be helpful to locate obviously that slope there, okay? Because we need to find that point and that point to create this sloped line here, okay? So in doing that, what I'm going to do is on the surface A, I'm going to measure up, okay? Because that face, sorry guys, that face is one plane. Okay, all of those points are on the one surface, so I can actually measure up 80 millimeters and then vanish back to find these 2 points up here. So I'll zoom out there. Okay, this point and this point are 80 millimeters high, so I'll vanish them back once I've measured up 80. So from A, I'm going to measure up 80 millimeters. 80 millimeters is right there. Where that 80 is, the face is going in this direction, so I'm going to vanish it over to VP2. Now, somewhere along that vanishing line is this point and this point. And what we want to find is the spectator's view of them. So once again, I want to find this one, project it down to the spectator, stop it at the picture plane. This one is already at the spectator because that was part of our cone of vision. And where both of these points hit the picture plane, what I want to do is project them down. Now there's one there, and this one will come all the way down. Okay, and that's going to help us find our edge. Now we want to get the bottom surface. Okay, and I know there's an edge running along here at the bottom. So that projects over. So I can start to actually build it up now. You'll start to see it now. So I'll heavy in this. I can heavy this guy up to here. And I can heavy in over to here. Okay, so we're on the right track. Now, what I need to do is I know I have a slope surface. So just coming back to our drawing, I know this is a slope surface here. So I'll just zoom in there. So this surface here is sloped, okay, and we have worked out that that is 60 millimeters high because it's 6 meters. So that point, I could actually, now this point here isn't 6 meters high, okay, but this point roughly, I could pick a point there and I could make a kind of a ghost point there that's going to be 60 millimeters high. And once I find that point, because I have this edge, okay, once I find this point, I can connect it down to here, and that will help me complete this surface here then. Okay, so that's what I'm going to do. Now I could have done it at the back, but I'm just going to do it out of this one. Okay, so zoom out there once again. This is the point that I want, that's at 60 millimeters high. So once again, using A, because it's all off the one face, I'm going to measure up 60. Okay, the face is going in this direction, so it's going to vanish over to VP2. Okay, sorry, it was this point here, that's the one I should have said. That was the one that was at 60. And I can see where it vanished over, it's after cutting right there. At that point right there, I can now connect it down to here. And that there has actually helped me find the slope. And if I was to extend this down, and there we have it. That is our face. You can see it's starting to build up now. Okay, so that's actually the front face of it there. Okay, now what I'm actually going to do is I'm going to work until it gets to the back surface here. Okay, because obviously we've got an edge there at the back, or a point at the back as well. So I want to find this guy. So to find this guy here, I want to get the view of him. I'm going to bring him down to my spectator, but once again stop it at the picture plane. Where it hits the picture plane, I'm going to project it down. Now, that point is going to be somewhere down along this line. And I know it's at the same height as here. Okay? And that face there, the back edge, is going in this direction. So which vanishing point is it parallel with? So you can see it's parallel with this one. So VP1. So from this point here, I'm going to vanish over to VP1. Okay? And follow it. Remember, it comes down here. So that's the edge there, right there, that point there. I'm going to use that in a minute. Okay, that's going to be helpful to me, that point right there. But now I'm also going to complete this portion of the chimney. Okay, this portion of the face is going in this direction, so in line with this, extend this across. Okay, likewise with the top one. Okay, so they're both going in that direction, and they stop right here. So once again, project this down to the spectator, stop it at the picture plane, and project it down. And that will actually help us complete that bit of the chimney there. Okay, and now I can actually see how much I can heavy this in at the back. So there we have it. Okay, so that's that bit there heavied in at the back. Obviously now you can see why I didn't heavy in all of this, okay, because obviously this portion of the chimney was in front of it. So we're nearly there. Now the next part of the question is we have to work on this chimney here. Okay, and there's a couple of ways you could do it. Okay, I think the best way to do it is using a height line. Okay, and it depends, it is your choice. You could take a height line off of this face here, coming down here like this, and then bring it down here and measuring up. That chimney has a height of 60, or you could actually bring a height line this way along this face, and that's the one I'm actually going to do. Okay, so from this face here, it's going to go parallel with this edge, so I'll just extend it down. So from that face there, actually I think it's neater and tidier to bring it out here to the left. Let's go off this way, just as long as it fits. I'll just check, and that should fit. Yes, it's going to go out here, but that's okay. So I'll do that one there. So there we have it. I'm going to do the height line off of this face right here. Just going to extend that down. This surface here, there's many different ways you can do it, and I'll do another one in a second just to prove to you. But all I've done is I've extended that face down until it hits the picture plane. Where it hits the picture plane, I am now going to extend it down to my ground line. So I'll actually continue my ground line out, because I can see it's after going outside of where I had it. I'm going to extend that point there, down here. Okay, and along here, this is actually a height line that I'm going to use to work out the height of this surface here. Okay, now we know that that surface, if I come back to the sheet, that surface there, okay, has a height of 6 meters, which is 60 millimeters. Okay, so that's where we're working from. So measuring up 60 again, marking the 60 in there. Okay, so there's my 60 marked in. Make sure it's exactly 60, it's about 60 and a half there. So that point right there is 60 millimeters high. Okay, and what we're going to do is we are going to help, it's going to help us find this face here. Okay, which gives me 2 points, this point here and this point here. Now, that face is going in this direction. So which vanishing point am I going to go to? Well, it's parallel with all of these. This one, this line, and this line. So if you follow that over, it's over here. So from this point, it's actually going to vanish to VP2. Okay? And somewhere along that, you can see here it's gone quite wide, so I need my larger set square to 3060. So, somewhere along that, let's stop it. You can extend it the whole way if you want. But you can see here I've kind of stopped it. And somewhere in along that, okay, is going to be this point and this point. Okay? How do we find them? Well, what we want is the spectator's eye view of them. So from the spectator to the point, stop it at the picture plane. Likewise with this one. Stop it at the picture plane. Where it hits the picture plane, project it down. That will give me one. That will give me another. Okay, so that's actually 2 of them I found now. Just drop my set square there. So there we have that one. Now I know that surface continues on down to the ground there, something like that, and this one is actually continuing on down here like this, and it's going to match up here somewhere. Okay, so at that point now, what we're actually going to do, and probably would have made sense, and I'll just show you here now. At this point here, it comes out, okay, from the ground, and we have that point in there. So this little portion here comes out like this, so that's in this direction. So which way is that going to go? Which vanishing point? It's going to go to VP2. So from VP2, I'm going to go out through the bottom. I'll extend it out there. That actually shows me where the bottom portion is, and you can see here I could extend it all the way back. Whoop, there's miles out there. There we go. Extend it all the way back, and now I can see how high I have to go up to here. So I'm just building it up slowly. You can actually see it. I'll work on this section in here at the very end. Now I've got this face here at the front to do, and that face is going in this direction, which is in line with VP1. So from here to VP1. And this one also goes to VP1. Okay, and it stops where this guy is. So follow him down. Okay, You can see where he hits the picture plane. That was one of the ones that was set up our cone of vision. Project that down. There we have it. That's that bit there. Then heavy this guy in. Okay, so you can see it's starting to build up there. And now the last little bit I have to work out is this kind of section in here, and it kind of helps me work out the slope there as well. Now, to work out the slope, what I would actually do is, the best way I actually find is, if I imagine this chimney wasn't here, kind of like we had this point and this point, okay, when we connected them up, I'm going to do the same thing on the opposite side. So if this chimney wasn't here, technically the front of this face would have kept going on, all the way on and on, right to here. And it was always at that height of 30. Okay, so I could use that as another kind of ghost point. So if I imagine the spectator saw that, project it down, hits the picture plane right there, and remember my 30 height was vanished back already, so where it hits the picture plane, project that down, and it's after giving me a point right in here. Now I know I can't see that, but that point there would connect up here in the same slope as this guy. But obviously it would just be a bit behind it, so I can connect that up. And there we have our slope. And having found our slope, I'll heavy that in just to there, because that's the bit that I can see. And this obviously comes down a certain distance. Now, on that one, okay, this is probably a little bit trickier because we're trying to figure out how far that comes down. Okay, on that one, what we're actually going to do is we are going to locate, okay, some points, okay, and the one I'm actually going to use, you could use it both ways. I could either do a line like this, or I could do a line like down like this. Just for the sake of, yeah, I'm actually going to do a line like this. I'll explain why, because I already have my line like that, so I'm going to extend it on. So I'm going to extend this on, okay. And what I've done there is I've essentially drawn a line up along that sloped surface from here. And the reason I've done it from there is because we already actually have that point down here. So just to go to my drawing, and I'll zoom in on it. What I've essentially done here is I have drawn this line here, and I have extended it, okay, I have extended it up like that. And by extending that up, it helps me locate a point up here on the top surface, okay? And because I have the point on the bottom surface, okay, I can find that line, which is on the slope. And what's interesting about that line is, that line then will actually help me determine where this exact point is, okay? By connecting up the slope line. So, using that slope line, which I have now drawn in my plan, okay, I have this one, I want to find this one. And what's interesting about that one is it's along that back edge there. Okay, so to find that, I'm going to project him down to my spectator, stop it at my picture plane. Where it hits my picture plane, I'm going to drop it down, but I know I only want it to hit right there because it's on that back edge. Where it hits there, I know it connects down to here, which is at this point right here. So I'm going to connect that down. And as you can see, I have now drawn in that slope line, but what's interesting is that helps me determine how far that bit goes up, and now I know this bit connects onto there. Okay, so there it is. That there, guys, is the perspective question completed out of the textbook graphics in design communication. A little bit in that there, guys, okay. Technically what we actually used was a couple of height lines, okay. We used surface A as a height line to draw this whole surface in there, and then we also projected down this one here. I could have also done this one. Now another example I'm just going to show you here is I'm going to use another height line, okay, just to show you another way I could have done it. So parallel with this face, I'm going to project down another height line off this face here. Okay, so put it in nice and heavy there. Now, you don't have to do this, but technically I've extended down this face to my picture plane. Hits the picture plane right there. where it hits it there, I'm now going to project it down, and from here I'm going to project up another height line. Now that height line, remember, our height originally over here was 60, so I'm going to do the same thing. Measure up 60 millimeters. And that 60 millimeters, okay, is going to vanish over, okay, I'm just looking here, so the face, remember I extended it down here, it's going to vanish, okay, just looking, getting confused, yeah, VP1, okay, to VP1. And what's important to note about that is, that point there is going to vanish to VP1, because look, it's going parallel VP1, and it's going to help me determine this point right here. And we know it's already there, so if I line it up with VP1, there you go, you can see it vanishes right through it. Okay, so that's just another way, and it shows that your accuracy is correct as well. You don't have to check that, but that's just another way. I could have taken, as I said, the height line this way, or I could have gone this way. Now I went that way because I just felt it was neater, okay, rather than doing it inside of the drawing. Okay, so for demonstration purposes, I brought it down here, measured up 60, and because the line was going in that direction, it vanished over to VP2. Okay, that's the question completed there, guys. Hope you found that helpful. Okay.